This brings us to our last theorem about roots of polynomial equations, and this last theorem is called Descartes' rule of signs. And here's what it says. Okay. The number of sign changes between consecutive coefficients tells you the number of positive real roots, or is less than, or is less than that by an even number. Now this sounds kind of complicated, but once we actually practice an example, it's actually not too bad. The second piece of Descartes' rule of signs says the number of negative real roots is the number of sign changes when we have p of negative x or is less than by an even number. Okay, and then I'm just going to underline a couple pieces here just so these pieces stand out a little bit. The number of positive real roots here, I'm going to underline. And then also the number of negative real roots. Okay, so this is only Descartes' rule of signs only tells us about the real roots. So if we think about real numbers, not complex, not our imaginary solutions. Okay, irrational numbers are real numbers though. So like the square root of 3 would be, I guess, kind of figured into this Descartes' rule of signs. All right, let's look at an example. So I'll call this example 3a here. And again, I know you're probably looking at this Descartes' rule of signs like, what on earth is happening here? But we'll look at an example and life will be a lot easier. So example 3a, what does Descartes' rule of signs tell you about the roots of p of x equals 8x to the third plus 2x squared minus 14x plus 5. All right, so Descartes' rule of signs tells us something about the number of positive roots, the number of positive real roots, and it tells us something about the number of negative real roots. We'll look at our positive real roots first, okay? So back at our theorem, that it says the number of sign changes between consecutive coefficients tells you the number of positive real roots. In my equation, I can see all of my coefficients, and don't forget that a coefficient is the number in front of a variable. So sign changes is considered when we go from a positive to a negative or a negative to a positive. So as we go down our line here, I start off with a positive 8. My next coefficient is a positive 2. Since I went from a positive to a positive, I haven't changed my sign yet. But now I go from a positive to a negative. So that's my first sign change. And then a negative to a positive coefficient I have two sign changes here. Okay, so again, it says my number of sign changes tells you the number of positive real roots, or is less than that by an even number. So what this means, we either have 2 or 0 positive real roots. Okay. Now, we don't know what those roots are. We don't know if they're rational or irrational. All I know is that if I were looking at a graph of this function, I am going to either see 2 or 0 x-intercepts on the right side of your y-axis, positive x values. Negative real roots is the number of sign changes of p of negative x. So we have to imagine for a second here that I take a negative x and I plug it in everywhere that there is an x. So I would take 8 negative x to the third power plus 2 times negative x to the second power minus 14 times negative x plus 5. Oops, I don't need that parenthesis there. Okay, so you take negative x and plug it in everywhere, and then see what your coefficients look like. Okay, if I have a negative number to the third power, it's going to be negative. So I would have a negative number times 8x to the third. If I have a negative number squared, it's going to be positive. So this would stay plus 2x squared. Negative 14 times the negative x would be plus 14x. And then plus 5. All right, now we've simplified. Let's count up our sign changes. I start off with a negative coefficient, and then I go to a positive coefficient. So that's one sign change. My next coefficient's positive, my next coefficient's positive. All right, so we have one sign change. Now again, we either have one sign change or an even number less. Since our even number less would be -1, we can't have -1 roots. That means we have one negative real root. Oops. All right, so we either have 2 or 0 positive real roots, and we have one negative real root. Again, it doesn't really tell us what these roots are or if they're rational or irrational, but kind of gives us an idea of what we'd be looking for if we were solving an equation after this.